All right, so ladies and gentlemen, let's take a look at lesson 4.4. We're going to be using the Pythagorean theorem and distance formula. For those of you who were here last year at Lakeshore, this is one of the things that we did end of April, early May, getting you guys ready for geometry. And so here we're going to see us using that. So let's build our vocabulary. The legs of the right triangle. So once again, we saw this yesterday with isosceles triangle. We talked about legs. They're the sides that form the right angle. So if we take a look at a rough sketch of a right triangle, these two sides would be our legs. The hypotenuse then is the side opposite the right angle in a right triangle. So this is the hypotenuse. So in a right triangle, you always have two legs and one hypotenuse. And then the distance formula is the formula that we use to find the distance between 2 points on the coordinate plane. And we can put anything on a coordinate plane, ladies and gentlemen. A map can be an example of a coordinate plane. But what that means is that you need to have two ordered pairs. So we have to have 2x and 2y to use the distance formula. All right, so let's take a look. The Pythagorean theorem. In a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. So sum means we're adding the squares of the legs. So if C is 90 degrees, so if we have that right triangle, then C squared, the hypotenuse, is equal to leg squared, so A squared, plus the other leg squared of B squared. So C squared equals A squared plus B squared. All right, so let's find the length of the hypotenuse. And that's what we can do. We can either find a leg or we can find a hypotenuse, because we have to be given two of the sides. So we're going to use the Pythagorean theorem to write the equation in the form hypotenuse squared equals leg squared plus leg squared. We're going to use that. So that's how we start finding that when they give me two sides. What I really wanted to do is look at what did they give me. And so usually what I do is I start with my right angle and I go opposite of it. X is opposite, which means X is my hypotenuse. So now it really doesn't matter which I call the first leg, which I call the second leg. I just need to make sure I've identified which side is my hypotenuse. So we're going to substitute values in. So we have X squared for the hypotenuse is equal to 5 squared plus 12 squared. We're substituting those legs. Your book says to multiply. I wrote that as squared. That's actually what you're doing, is squaring 5. So that's 25, and this is 144. You then have to add. So basically, ladies and gentlemen, we're just following order of operations here. And so when we do that, we get 169. Then you have to find the positive square root. We're finding a length. And so we have to keep in mind that our final answer is always going to be positive. So we take the square root of each side. So the square root of x squared, we take the square root of 169. And when we do that, we get x is equal to 13. So the length of the hypotenuse is 13 units. I don't know whether that's feet, inches. They didn't label the side. But I know that it is 13 units. All right. So like I said, you can use it to find a hypotenuse or you can use it to find a leg. We want to find the unknown side length, so I'm going to start at my right angle. I'm going to go across. 14 is opposite that, so I know that that's going to be this time what gets plugged in for the hypotenuse. So we start with the formula, hypotenuse squared equals leg squared plus leg squared. Plug in what you know. Hypotenuse this time is 14. The leg we know is 7 squared, and then the leg we're looking for is labeled with x. Do the squaring that you need. So this is 196 for 14 squared. 7 squared is 49, and then we have plus x squared. We need to isolate. We're solving this equation now, so we have to subtract 49 from each side. And so we get 147 is equal to x squared. We're always taking that positive square root as our last step, so we're going to take the square root of 147. Notice, ladies and gentlemen, it says to approximate with your calculator. And so what that means is you're going to have a calculator with you while you do this stuff. We're going to round to the nearest 10. And so we're going to have 12.1. This should be approximate. I didn't type in the right symbol there. So we finish off with saying that the side length is about 12.1 units. So, ladies and gentlemen, your checkpoints and on your own, all right? If we look here, I'm going to start you off by letting you know that this is your hypotenuse. So you're going to make sure that you're plugging that into c squared is equal to a squared plus b squared. So you found your 10 there. So this is going to be 10 squared for your hypotenuse. I'm going to put 6 squared here for my a, and then plus x squared. So you guys can fill that out. I'm going to leave 2 and 3 for you to do on your own completely, ladies and gentlemen. And these will be to check in class on Monday. All right, so now what we want to do is take a look at this distance formula. So if we have 2 points, A and B, and they're defined by x1, y1 for the points of A, and then x2, y2 for the points of B, then the distance between those is the difference in the x's, so x2 minus x1. I have to find out what's the distance here. I need to know how long this is. So if I do x2 minus x1, I then want to find the distance here, and I have y2 minus y1. All right, notice, ladies and gentlemen, we do end up making a right triangle there. So our distance formula is connected to that Pythagorean theorem. And in fact, that's going to be one of our follow-up questions that we talk about on Monday. So we want to use the distance formula for this problem. So we want to find the distance between D and E. So here's D, here's E. They tell me that point D is the point 1, 2. They tell me that E is the point 3, negative 2. All right? So with that, that means x1 is going to be 1, y1 is going to be 2. That means that for E, being my second point, my x2 is 3, and my y2 is negative 2. So we need to fill out that distance formula. The distance formula, the length of DE, is equal to the square root, because we're using the Pythagorean theorem, we have the square root of that at the end, of x2 minus x1 squared plus y2 minus y1 squared. All right, so we now start substitution. We do the values we know. Keep your square root in there. We're going to take our x2, which is 3, minus our x1, which is 1, square that. We're going to take our y2, which is negative 2, and subtract our y1, which is 2, and then square that. It says to simplify, so we're going to take the square root, and we're going to have 3 minus 1, which is 2 squared, plus negative 2 minus 2 is negative 4 squared. And ladies and gentlemen, the book doesn't show up, but I would suggest keeping square roots around all of that. You then need to do the square roots of those. So this is the square root of 2 squared is 4, plus negative 4 squared is 16. That equals the square root of 20. You're going to approximate that on your calculator again, and we're going to round to the nearest tenth. Okay, and so that's going to approximately have a length of 4.5. So once again, we say the distance between D and E is about 4.5 units. So our follow-up, can example 3 be done with the Pythagorean theorem rather than distance formula explained? We will do in class, and in fact we will do a warm-up with that, show you how this is our distance. Our distance formula is just a continuation of that. But what we want to do now, ladies and gentlemen, is actually do this together. So we're going to label our points. We've got D as being the ordered pair 1, 5. We have E as being the ordered pair 3, negative 2. My formula, the distance formula, is the square root of x2 minus x1 squared plus y2 minus y1 squared. So you can see the sum of squares, guys, so that's what should lead us to see the Pythagorean theorem. So what you need to do in class is you need, or for your checkpoint here, is you need to finish the formula and simplify. Do not take the square root of it. Leave that so I can see all the work that you're doing with that and show your steps. And we will go over that in class on Monday. Have a wonderful weekend, ladies and gentlemen.